In this segment, we'll do a series of in-lecture questions involving joins on database Bakery 1, and we'll introduce a new clause or two of the select statement along the way. Now, here's a sequence of further join examples to try out on our database Bakery 1. Number 1, write and test a single SQL query using a join that shows the first and last name of all customers who had receipts on 2007-10-7. October 7th, 2007. And you may get repetitions of some of the names, and this is okay for now. You should get 10 results. And what you should have gotten was something like the following. Select a first and last name from receipt and customer, where the purchase date is as specified and customer ID equals customer.id. And if you wanted to qualify customer ID with receipt dot, that would work, but is not needed in that case. Oh. And remember to do that. And there is our 10 results, with some repetitions, of course. Now, this is a fairly direct revision of the example join from the prior segment. We're still joining customers and receipts. We're just filtering by date of receipt instead of by first and last name of customer. Let's try another one. Why does it show some names twice? If you're confused by this, try running the same query with select star to see the other columns of the joined rows. And the answer to that is that the problem is that customers who have several receipts on the day in question are listed once for each receipt. You can see that easily enough with the star I indicated here. So Sixta has two different receipts on the same day and is thus listed twice. Now, always remember that MySQL implements the join as a Cartesian product, a list of all possible pairs of rows from the tables. It's not trying to list each name for you once. It's just generating the product and providing all rows that match the where clause. And if a customer has several receipts for the day, then the Cartesian product will have rows pairing that customer with each receipt, and you'll get repetitions if you don't indicate otherwise. So given the Cartesian product's obsessive combine every row with every other row behavior, it's no surprise that unwanted duplicates arise in join queries. If we really want each customer who had a receipt for that day listed just once, then how do we do that? We do it by adding the keyword distinct to our query. So select distinct, first name, last name, from receipt and customer, and of course then where purchase date and customer ID match. And as you can see, we get now each first name and last name listed just once. Adding distinct to a query means if the query results in duplicate lines, display only one of the duplicates. So now we have the fully correct query, or do we? There is still a subtle but important bug, even in this corrected query. Given the right database contents, distinct could remove a first-last name pair that it shouldn't, and a customer who had purchases on the date in question would be omitted. Now, the problem doesn't show up for the current Bakery 1, but for other reasonable content it would. What is the bug, and with what database content would it show up? And the answer is that if two customers have the same first and last name, then only one will be listed under distinct first name, last name, even though they are two different people. Now, fixing this problem takes a bit of thought. What we need to do is list more columns in order to make each customer distinct from every other, even if they have the same first and last name. So given that hint, how would you change the query to fix this last subtle bug? What we need to do here really is to add customer ID to the selected columns. So we would have select distinct customer ID, first name, last name, from receipt customer, thus. And, of course, the qualifying where clause to follow it to complete the thing. And we'll get the same result in our database, but in the other case, it would have corrected the problem if there were a problem. The addition of ID also, by the way, makes the listing more useful. Knowing that there are, say, 2 John Smiths that meet the criterion isn't too useful unless we can tell which John Smiths they are. So including customer ID provides unambiguous identification of the customer in cases where first and last name doesn't, and it prevents distinct then from dropping same named customers from its list. So on to question 5 here. Use a join to write a query that shows all dates on which a product with ID or the product with ID 25-STR-9 was purchased, and list those dates in increasing order of date. And you should have arrived at something like this. Select distinct purchase date from receipt line item. And again, we'll need that distinct, right? Because there could be multiple purchases on the same date. And then the where clause, where receipt ID equals ID, and product ID is the product ID specified, and order by purchase date. And there's our 9 rows. Now this is very similar in spirit to the earlier examples. The query joins line items with receipts to get all receipt line item combinations where the receipt IDs match, and it uses distinct to remove duplicate dates, which otherwise would arise if there are several receipts involving the product on the same day, and it orders the results by purchase date to get the result in chronological order. A couple more questions on this query though. First, why didn't we add a prefix to ID right here? Why didn't we make that receipt ID in the where clause? An earlier query required customer.id, and why was it not necessary to add an ID column to the selected columns in this case when it was needed in the prior query? And the answers are that first, the Cartesian product rows from joining receipt and line item have only one ID column, receipt ID, so we don't need to disambiguate with a prefix. And then second, in the prior query, we wanted 2 result rows for 2 John Smiths as long as they were really different people. But if we're just looking for dates on when we sold strawberry cake, then we don't want to repeat the date even if multiple receipts, including a line item for that, appear on the same date. As the final step in this lecture, let's print the first and last name of everyone that has ever purchased strawberry cake, 25-STR-9. And this requires a bit of discussion. From the prior work, we can get receipts that go with 25-STR-9 line items by joining receipt and line item, what we just did. And we can get customers that go with receipts by joining customer and receipt, earlier query there. Now we need to join all 3 tables in one grand Cartesian product, combining customers, receipts, and line items in all possible ways, at least in principle. The query optimizer, as we said earlier, will do it more efficiently. And then we need to select just those combinations we want. Ones where the customer corresponds to the receipt corresponds to the line item, and the line item is for a sale of 25-STR-9. So, as a first step, how many rows will this query return? And for gosh sakes, don't run it. Just reason it through. If you run it, you're going to wind up having to kill your MySQL session. And so the answer is there are 20 customers, 200 receipts, and 557 line items, and an unconstrained Cartesian product of these 3 tables produces 20 times 200 times 557 is something on the order of a little more than 2 million rows. So we don't want that. Instead, limit it to the combinations where customer, receipt, and line item correspond, and where the line item is for the purchase of 25-STR-9. You'll need a 3-term where clause, and you should get 10 results. And just do a select star for now so we can see all the columns. So you should have come up with something like this, where you are joining customer ID and customer.id and customer ID, and receipt ID and then the product ID as indicated, and we come up with 10 rows. Now, running that, you can clearly see the three-way Cartesian product at work. In each combined row, the first three columns are from customer, right here, and then the next three are from receipt, right there, and the last three are from line item, right there. And of course, the customer IDs match up, 7 and 7, for instance, as do the receipt IDs, 83085 and 83085 on that first line. And all the line items, of course, are only for product 25 stir 9. Now let's change the star to distinct first name, last name, and reset. And here's a rule of thumb worth remembering. To avoid unconstrained Cartesian products in a multi-table join of, say, n tables, you need n minus 1 foreign key equals primary key clauses in the where. If you're joining two tables, you need one such clause. With three tables, as we just saw, you need two such clauses, and so forth. It should be almost a reflex to check the number of fk equal pk clauses to be sure it's one less than the number of joined tables. There are a few cases where this rule wouldn't apply. For instance, if you wanted to list all combinations of rows, or if the foreign key equals primary key clause is indirectly accomplished via other conditions. But 99% of the time, this rule applies. And a final question here, or question 9. Write a query for high-end customers. This one prints first and last name plus any other necessary customer columns without repeating any customer for anyone who has bought any product with price greater than $12. And this, as you might guess, will take a 4-table join. Using every table in the database, you should get 19 results. So, after perhaps a bit of thought, you should come up with first this. We're going to select distinct customer ID, first name, last name, from those 4 tables. And then a where clause to do the necessary linkups with IDs and choose price greater than 12. And there are our 19 rows. And you can see the 3 fk equal pk constraints in there for the 4 tables. It's really just a simple extension of the prior concepts. Now our Cartesian product rows will be a concatenation of a customer, a receipt, a line item, and a product, and with the pk's and fk's all matched up and with price meeting the stated criterion. Customers with expensive tastes might have multiple high-ticket line items and thus might appear repeatedly, so we need the distinct. And customers may still have the same first and last name, so we still need the customer.id to make same-named customers distinct and to have some way of telling one from the other. And then one final touch. It would be nice to have those customers listed in alphabetic order of name. We already know how to use an order by for a single column, but you may also list multiple, comma-separated columns after order by. If you do, the query uses the first listed column as the principal sorting key, but if 2 rows match on that first column, then the order by breaks the tie by using the second listed column as the secondary sorting key. And if you list 3 columns in the order by, it uses the third column if the 2 columns match, if the 2 rows, match on the first 2 columns, and so on. Any column in the order by is used only for rows in which all prior columns match and a tie must be broken. So the final question then, please use that to augment the query from question 9 to list customers in the usual order by last name and by first name within sets of customers having the same last name, like the Espositas in Bakery 1, who both evidently like expensive cake. So what you should come up with on that is the addition of order by last name, first name to what we had already before. And you can see that they are now listed by last and then first in alphabetic order. Now, once you've done 4 table joins, it's pretty easy to extend to as many way joins as you need. In the next segment, we'll add a couple of new tables to Bakery 1, giving an opportunity for even longer joins.